be quickly sharing my screen. Let me know when you can see.
Yes, we are able to see.
Yeah. So the topic is pattern recognition and AI. So here we'll be talking about how important pattern recognition is in terms of making an intelligent system, or that we call an artificially intelligent system. So in AI, what we tend to do is we want a system or a machine to work like a human brain. So that is what we try to achieve. And there's what pattern recognition is a very important topic which comes into the picture. It is very important there for a system to recognize a pattern in something as a human brain does, and then take some intelligent decisions. So, starting with the what is the pattern recognition in general? So, if we talk about schools, in school, students are asked to fill these missing words like ABCD. Like some blanks will be there. There will be some number sequences, and we will be asking the student or a child to predict with what number will be the next, or this dot to dot matching, we will have a drawing and some dot with this numbers marked on it, and we'll ask the child to draw join these points and create a figure. Also when like mom teaches our kid like 1 2 3 multiple time, and after multiple repetitions, when the lady says 1 2 and child responds like 3, that is where we can see the child has recognized the pattern, that yes, after 1 2 3 will come. So everything in the real world, or a human, for a human brain to detect yes this is happening, we recognize a pattern in things and then take decisions. So these all are the use cases, some of the use cases of pattern recognition itself. So now, as a introduction, a pattern is a short description of data, and pattern recognition is how agents make predictions, which is a central problem in AI. Now, what will happen is, let's say I have series of data. Let's say I have huge data. I will, in order to get some insights out of it, I will try to break down it into small chunks. That is a generalized form of that data, and that small chunk is a pattern which I am taking to make some decisions or like that. So I am seeing that there is a pattern going on. Today there will be a temperature rise. Then tomorrow there will be some more temperature rise. Then after 3 days there will be a fall in temperature, and this pattern is going every year. So I will be able to make predictions like yes, in a year, 365 days, this is the pattern which is followed since last 10 years. So I will be on little differences, I will be able to predict that yes, this thing will be the next what I will see. So the recognition of a pattern can be done physically, mathematically, or with the use of algorithms. So what we will be discussing here is, I will be telling what all the components pattern recognition system has, what all types of, what all are the approaches we can use for pattern recognition, and what all are the different algorithms which are being used to do this thing in different spaces. So also the application of pattern recognition. Then if we are interested more into going into detail of the algorithms, I can also tell how these algorithms are being implemented as well. So yeah, this will be the agenda of this presentation today. So yeah, First of all, I'll be telling you like what are the, as you see, the basic components of the pattern recognition system. So in the real world, there will be some sensors. So sensors can be anything, whether there is a image, whether it is a text, whether it is what we sensory thing. So whatever there is a real world, like in the real world, there will be some sort of sensors. Sensors can be of any type. Then we will have that data or that sensed input will never be so pure for us or the system to make some prediction out of it or recognize a pattern as it is. So there will be some pre-processing happening and some enhancements happening on that data. Then what a machine will do, it will extract some features. Now what is the feature? Feature, like, stop me if I'm going very fast. Yeah. So a feature is like, let's say I have in the real world, I have a picture has some, let's say a rectangle I have, and that rectangle have sides, length, like length and breadth and area. So this length, breadth, area, these are the feature of the real world object which is getting sensed. Now what my machine will do, on the basis of these features, there can be three things happening. Either I will be assigning that particular sensed element to a class, or I will be assigning it to some cluster, or I can do some like analysis on it, putting some algorithm, and I can get a predicted output. So three types of processing can happen on the basis of this pattern recognition. And then based on inputs outputs feature, my system will be intelligent enough to adapt on the given data, like any kind of linear or non-linear data coming into it. It should be able to perform a clear clustering or class alignment or variable predictions like that. So these will be the basic generalized components in the pattern recognition system. Now, going ahead, like how this pattern recognition works. Now what it looks for is, it looks for the available data, try to see that whether there is some regularities in that data. So this checking of regularity and making some predictions will have majorly two parts. One is explorative part and descriptive part. In explorative part, what happens is, the algorithm will look for the patterns in general. So there will be a set of input given to the system, and it will try to make a relationship between its features and between its feature and the end class to which it belongs, and it tries to make a pattern out of it. Then in descriptive path, now my algorithm is trained enough, and then it will, on the testing data set, it will try to start categorizing the found patterns. So there are basically two parts there. One is when this algorithm will look for the pattern in general, and then it will categorize that pattern. So this is how the basic pattern recognition works. Now, the data for the pattern recognition can be anything, like text, images, sentiments, emotions, sound, and like it can be anything. So if we talk about it's a huge, what we say, pattern recognition is a vast topic. Inside it, there will be a small separate topics which will cover different types of things, like just like text and word. If we go for pattern recognition in text and word, there comes the natural language processing. If in pattern recognition we are going to for images, it will be part of what we say computer vision or image processing. If we go for sentiments, it goes for sentiment analysis. So like that, pattern recognition itself is a vast thing, and within that we have different kind of recognition based on what is the input given and what is the expected output for it. So yeah. Next. So as you can see in the chart, there are some aspects of pattern recognition. So the very first thing is data acquisition and pre-processing. So as I said, data will never be in a usable format always. So there is a huge amount of data coming in. So I need to perform some pre-processing onto it. Then I will make it a good data representation, and the decision making comes into the picture. So what happens is gathering data, incoming or existing, then cleaning of the data will happen. Then system will look for patterns and similarities. Then data will be segmented according to the findings, and it will be in a format that analysis can be inference can be pulled out of that data, and those insights or inferences can be implemented to your business and get the results. So this process keeps on repeating, and my system keeps on learning things and adapting to whatever the non-linear data coming in, or like whatever type of data is coming in, it will repeat, adapt to things and give me proper business insights. So yeah, this is one of the thing. Now in terms of approaches, there are basic like usually four types of approaches which pattern recognition system adapts is concept modeling, object modeling, system modeling, and generalization. Now these four approaches has some are categories which include some of the things like just like system modeling includes neural network and vision. Object modeling includes synthetic pattern recognition, structural pattern recognition, case based. Now these all are different kinds of things, like just like syntactic pattern recognition means what, there will be a structure, let's say I have an image of some objects, and those images are formed with the small subunits. Let's say a box is made of like six rectangles like that. So that a rectangle will be a sub pattern in the complete image, and then that pattern is then used for further this thing. So that is how structural pattern recognition is there. So instead of extracting features like length and breadth, I will be fetching out a structure out of it and do further processing. Then case based, like there will be some reasoning, what we say rules will be there, and then that is used to classify my and what we say classify my input or training data set. And there will be statistical pattern recognition. Statistical pattern recognition is not but extracting features like length, breadth, color, area, all these things. So broadly, pattern recognition approaches are classified into four major groups. Those are concept modeling, object modeling, system modeling, and generalization. So I'll be talking about three of them here. Yeah. So very first one is statistical pattern recognition. If you see here, there will be a sensor, some representation, and then generalization. So let's say this particular shape has some area and some perimeter. So area and perimeters are my features. So based on area and perimeter, I will be classifying these dots. If you see this line, this line divides my complete data sets into two classes, that is A and B. So in initially these dots will be of single color. Now what happens is my system extracts the features like area parameter from the system and classify these into the two groups, which are A and B. So it identifies the pattern that nearly this area and this parameter thing belongs to this group, and then plot it like that. So yeah, next will be syntactic pattern recognition. So last one was more on to feature extraction. Syntactic pattern recognition is more on to structural aspect of it. If you see, there is a background N, there is a um, floor M, there is a object face Y, Z, X. So what this particular approach does is it will fetch out the simplest sub patterns, which are called primitives of the input, and then it will form like in terms of pattern is then described in terms of interrelation of these primitives. Like let's say floor is there, background N is there, and this system will find these relation between floor and the background. So this is how it works. So there are grammatical rules that commands the model like to have to be inferred from the available training example. So major example for this is letters of the alphabet. So there will be a word formation, there will be a sentence formation, and then some grammatical rules that will be there to drive those inferences and predictions. So this is syntactic pattern, which emphasize on structure more than the features. Then comes is neural pattern recognition. Now what happens in neural pattern recognition, there will be many parallel computing systems. Like there will be a system which have small so many processors, and they will be interconnected to each other. Now there will be some input, there will be some output, and my system will have some weights or some parameters associated with each processor. Now my system will try to adjust itself on the basis of input and what it should have the output. That is basically known as back propagation. When my input is known, my output is known, and my system will try to adjust itself in order to get the same output in any kind of input which is supplied. So this is a neural network approach, which is like basically taken for the non-linear input, where I am not sure what will be my input coming in, but I have a huge data set onto which I am going to train my system. So if you see here, weights and biases, these are the parameters associated with some function, and the system has input and the output, and it tries to adjust its W and B in order to get the output. So basic example for this is digital character recognition. So it has this A in input and it gives this A in output. So optical character recognition is one of the example of neural pattern recognition. Yeah. So there will be many algorithms. So I have taken only three types of algorithms. So I came across five or six. So there will be some classification methods. There will be some clustering methods. There will be some cluster regression methods. Now classification method is like I will have three classes. Let's say, for example, three classes defined. I have a data set, and I am like asked to um, classify my the data set into those three types of classes. Let's say I have a blue box, I have a red box, I have a black box, and I have balls. Now those balls, on the basis of features or whatever it is, uh, I will try to categorize those balls into those three boxes. So that is the classification. Now clustering. Clustering is like group. it's similar to classification, but I will in clustering nearest things comes into picture. Like for example, I have certain points plotted, and I will see for the nearest things. Whatever is nearest to me will tend to be in my group, and whatever is far away from me, that will not tend to be in my group. So this is how clustering things work. Now then regression method comes into picture. In regression method, what happens is there are certain features, or like there are some certain independent features or variables which are tried to adjust in order to find a dependent variable, that is an output variable. So there are so many algorithms here. So we can take each algorithm in each of the session if people will be interested. So I can take these algorithms, the implementation of it, and then we can take it ahead. Yeah. So yeah, now then applications. So some of the examples are like computer aided diagnosis. For example, this is basic example of like image processing, when some scientists, Japanese scientists, were able to identify 5 types of cancer cells using this. Yeah, pattern recognition and image processing. So many similar projects in health care system is a step towards automated diagnosis and disease prevention. Then next is natural language processing for chatbot. For example, if you see there is a test chunk and my system is able to find out some inferences, like this chunk is talking about London, UK's capital, and most popular city is England. Okay. So this is language. This is an example of pattern recognition. Then optical character recognition. So if we have Google Glass, so it will convert this type of optical characters and show it to me like this. Then sound and speech recognition. So this sound, voice, speech recognition is similar to optical character recognition, but the input will be sound, voice, or speech instead of an image. Then image pattern recognition, like this finding an animal into the picture. So if you can see there is a squirrel, and it recognizes, system recognizes that yes, it is a squirrel. Then sentiment analysis, so mood, opinion, intent can be part of a training data set for machine learning and pattern recognition. So besides simply recognizing the face of the person, the algorithm's purpose is to define the nature of the facial expression, that what is it means, whether it's sad, angry, or happy. Then big data analytics. Usually data can be like analyzed with the help of Excel sheets or other more advanced tool. But to analyze big data, however, you need help of machine learning and pattern recognition. This can be used in such industries like stock marketing, forecast, ad tech, martech, business, where the events or day can reach several millions of items and others. So Google Analytics and their insights are also an example of pattern recognition technology in action, because it doesn't merely track what is happening onto your website or mobile app, but also spikes and possible reasons for it. It will give you. So yeah, and now why it is so important? Because pattern recognition technology simplifies the analytics results and provides a reliable source for business intelligence insights, which is a critical thing for an organization and decision making. Yeah. So any questions here? Hello.
Not from me, Pallavi.
Okay.
I had a doubt about the different algorithms used, but then you cleared it afterwards, the classification and then clustering and all.
Okay.
Okay.
Okay. So yeah, that was it. So anybody?
Pallavi, I have one very
Yes.
simple question. Probably I can understand once you will elaborate. So,
Mm-hmm.
initially, you have used one word agent
Mm-hmm.
while describing the PR. So, what exactly that defines the agent word?
Where here? In
Second or third slide.
this
Yes.
one. Yeah. So
Yeah, yeah.
basically, agent here is describing a system which is used to make the predictions. It can be a computer. What? Hello.
Sorry, you were saying something.
Yeah. Yeah. So I was saying that it is basically a system which is used to make predictions.
Okay, got it.
Hmm. Yeah. Okay, so I wanted to know if anybody is interested in exploring these algorithms.
Like, I don't think we all know like what exactly like in depth each of the algorithm is, but then if we get to know it, maybe we could find some use out of it. I mean, definitely it's useful, but then we'll have to look into this, I think.
Yeah, so if people are interested in exploring these algorithms, so yes, I can. We can talk about these algorithms in separate sessions, AI sessions itself.
Hello,
Yes,
hello Pallavi. So
yes,
I wanted so there you could have given some good examples of how pattern is recognized. Like one of the best examples is NBA. Like they are using the pattern recognition for how the people are playing the game. They are tracking their moves. They are doing analytics on that based on AI. The images are
mm-hmm.
generated based on their moves, and that is being studied by the other team. Like how they are playing, how
Mm-hmm.
their pattern is. So you could have added that example, or maybe when you're explaining these things, try to show some kind of like in-depth examples, like real life
Mm-hmm.
application where it could be implemented.
Okay, okay. So yeah,
NBA
uh,
is one of the best examples for this pattern recognition. Try to search on that.
okay, sure. Yeah. Anything else we can talk about? Okay.
I
Okay.
Huh?
wanted to say that like if we have to have any interest in exploring these algorithms, the basic problem what I faced yesterday, like I had a call with Samudra, and I was trying to figure out how to use Java and things like that. Okay. But the basic problem was that I was not able to use the tool that is required to do Java coding, because in class 10th and 12 we used to do in Notepad and all that stuff. So we already had a server. So how to use it, how to like practically get an experience on it or interest in it, how do we do that? If that is being addressed, that would be a little helpful, maybe. Like literature is one thing, but when you see it happening, that is a different thing.
Yeah, so that's why I'm asking if we are interested in that is one of the reason I'm not taking code here. But yeah, if we are pretty much interested in that, we can have working sessions on this where you can see these algorithms actually working.
Yeah, yeah.
Yeah, so that's what I'm asking, like if more people are interested, so we can take these algorithms maybe in one AI sessions, and so we can work it out like that.
Yeah.
So
I
if I can know who is in for that.
I am in for it.
Okay.
Yeah, same. Like, I
Anybody?
think you can figure out which topic would be much like interesting, and then you can give this thing walkthrough it.
Okay, for me, these things are actually interesting because when I explored and implemented these algorithms, I was like, yeah, yes, this is pretty much interesting. So I will take one by one, and yeah, I can show it to you.
Yeah.
So yeah, okay. Then
Okay.
people should not say that yeah, we don't understand the code. Yeah.
It will be difficult for non-technical people to understand the code, but yeah, matlab once they get a hang of it, we might not understand the code even after for a very long time being exposed to it. But
Mm-hmm.
yeah, we see
Mm-hmm.
what it is doing, then we might understand ki, okay, this might be linking to that.
Okay. Yeah. Okay.
Okay.
So anything else? Anybody'd like to add?
No, nothing from my side.
Okay. Yeah. So I'll stop sharing if nothing. Yeah. So thank you guys. Thanks for joining and your inputs. We'll try to resolve these things. Whatever consent you are sharing. Yeah, we will be covering algorithms in next sessions. Thank you.
Okay. Thank you.
Okay. Thank you for the
Bye.
session.
Bye bye.
Thank
Bye.
you. Bye bye.
Thank you. Bye bye.
Mhm.
Okay, thank you, Kalyan.